there, everybody. This is What's Up with Giancarlo. So today we're going over lesson 16.2, which is mean absolute deviation. All right, so this is a little tough, okay? I will be calling it MAD as a acronym for mean absolute deviation. And what the MAD is how far is the number from the mean That's basically what it is, and then you do the same thing as the mean. You get all the numbers you get every number and see the distance it is away from the mean, and then you add them all up, and then you divide by the amount of numbers. So let's go through this. Here we are, understanding mean absolute deviation. A measure of variability is a single number used to describe the spread of a data set. Okay? The spread of a data set. It can also be called a measure of spread. One measure of variability is the mean absolute deviation, or MAD, which is the mean distance between each data value and the mean of the data set. Okay? So the data represent the height and feet of various buildings. Find the mean absolute deviation for each data set. So this is how we work it out, okay? First things first, we find the mean, which is we're adding all of these together. One, two, three, four, five, six, seven, 8, 9, 10. We're going to add all of them together and then divide it by 10. Okay? So that's what we do here. We add them all up, divide it by 10, we get around 59. Okay? We get around 59. It's round to the nearest whole number. That's what they wanted us to do. So it's different, but then we're just going to say it's 59. So when you add it all up, it's 591. And then when you divide that by 10, you get 59.1. But we round it to 59 because that's the nearest whole number. So 59 is our mean. Okay? So this is 1 away. This is 1 away. This is 5 away from it. Okay? This is 3 away from it. This is 4 away from it. This is 6 away from it. This is 3. That's 0. That's 3. And that is 1. Okay, so now you see how we took the distance away from the numbers from the mean? Then, see, it's all right there. Now calculating the mean, the MAD would be adding all of these together. And then dividing by the amount. Okay? And yes, the 0 still counts. Always count this 0 as one of the numbers. So then we add them all up, we divide it by 10, and then our mean absolute deviation would be around 3 because it says round to the nearest whole number. If we add them all up, we get 1, 2, 7, 10, 14, 20, 23, 23, 26, 27. 27 divided by 10 equals 2.7. So this is our legitimate MAD. But they say round to the nearest whole number. So this would be about 3. Okay? That's all we're doing. MAD, or mean absolute deviation. Bless you, thank you. MAD is taking all the numbers and finding the mean. Once you find the mean, You find the distance between the mean and the numbers for every single number, and then you find the mean of those new numbers. Okay? Please rewatch that, rewind it, figure it out if you don't understand. It's all right there. That's the whole entire lesson, math. This whole entire lesson is mean absolute deviation. Okay? So we're gonna do another example. We add all of these and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. Add them all up and then divide by 9. Okay? I don't feel like adding them all up. So here it is. They add them all up, you divide it by 9, and you get about 50. So if you add them all up, you get 449 divided by 9, and that equals 49.8, and it just keeps going. Okay, 8. Okay, so so we're gonna round that up and say it's about 50 because it tells me round to the nearest whole number. Okay, so we have to look at all of these numbers, and find the distance from them to 50. So from 46 to 50. We'll say it's about 50. We don't want to say it's exactly 50 because it's not. So these squiggly lines mean it's about. Okay, it's like the equal sign, but it's not exactly equal 50. It's about 50. Okay. So from 46 to 50, it's 4, 3, 6, 2, 4, 2, 7, 2, and y 5. Okay. So we add them all up. We get 4 plus 3 is 7, plus 6 is 13, plus 2 is 15, plus 19, plus 2 is 21, plus 7 is 28, plus 2 is 30, plus 5 is 35. It's 35. And then when you do 35, we're going to do this way. We're going to do long division. 35. 9 goes into 35. 3 times, get 27. And then I'm going to get 8. And then I'm going to have to put a decimal point and a 0. And then I put a decimal point up here. And then I put the 0 down there. And then 9 goes into 80. 8 times. Then I get 72. And then I'm gonna get another 8. So it's gonna keep going 3.8. So when I get 3.8 with a line over it, round to the nearest whole number. Woohoo! I like that. So just looking at this nearest whole number, mad is about 4. And let's see. Boom. Boom diggity. Boom diggity dog. Okay? Everybody understand that? Good. Okay. Using mean absolute deviation. The mean absolute deviation can be used to answer statistical questions in the real world. Many of these questions may have implications for the operation of various businesses. Okay? So, a chicken farmer wants her chickens to all have about the same weight. She is trying 2 types of feed to see which type produces the best results. All the chickens in pen A are fed premium growth feed, and all the chickens in pen B are fed maximum growth feed. Okay? The farmer records the weights of the chickens in each pen in the tables below. Which chicken feed produces less variability in weight? Okay, so this is a lot of chickens. Okay, look at all those chickens. All right, so these are all the weights of the chickens. First things first, I'm the realist, okay? But no, seriously, first things first, mean. We find the mean of all of them, okay? So we add them all up, and then we divide by 1, 2, 3. They don't tell me there's 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we add them all up, divide by 10. Add, divide by 10. Add, divide by 10. So they do it all for you, okay? So pen A, the mean, not pen A like pen A vodka, pen A, where they keep all the chickens, the mean is 6.3, about 6.3, okay? Nearest 10th. Round your answer to the nearest 10th. Always pay attention to the directions, class. Always. About 6.3. The second one, pen B, is about 6.7, okay? So find the distance from the mean for each of the weights. So the distance from the mean, this was, we had 6.3 and mean 6.7. Okay? So we find the distance away from the mean for all of these, and then the same for all of these. What do we do then? Add them all up and then divide by 10. Okay? So it's the same thing all over. So you're finding the mean of the actual numbers that they give you in the first place. You find the distance away from the mean, distance from the mean, and then you find the mean of those distance from the means. Okay? You know why they call it mad? Because it makes you mad, man. Okay? So, since pen A's mad is less, premium growth feed produces less variability in weight. So that means that it's the closest to, all of them are closest together. Okay? This is there's too much of a varying aspect of it. Okay? They range from too small to too big or whatever. This is all closer to the same weight. That's what they mean. Okay? All right. All righty then. I'm going to let you guys do your turn, and then this is it. I don't want to go through the rest. You ready yet? Okay, that was terrible. All right, you guys should be good now because you should have paused already. So why not? Um, okay, let's look at this. Two waiters at a cafe each served 10 large fruit smoothies. That's important. Now we know there's 10. So, which waiter's smoothies showed less variability? So, the smaller mad is the better mad. Okay? The smaller mad is the better mad. So, what I'm going to do, I'm going to add them, add, divide by, divide by 10. Add, divide by 10. Okay? So my mean is about 20. And my mean is about 20. Woo! Okay. So we find it all. We get 0.9, we get 0.1, we get 0.9, we get 0.4, we get 0.9, we get 0.5, we get 0.8, we get 0.6, we get 0.3, and we get 0.9. Okay? And there's not enough space, but you do the same thing for all of them. You add and then divide by 10, okay? The MAD for waiter A is 0.6 and the MAD for waiter B is 0.2. So waiter B smoothie showed less variability. Therefore, the answer is B, and then here's a little more work. Nope, same thing as that, okay? If you need any help, just ask in the comments, ask me, do whatever you please, okay? Okay, I'm here for you. Okay, that is the end of the video. Okay, so everybody remember, you're watching this, you're part of the class. See you next time, everybody.